Here's a clear, practical deep dive into Kubernetes API Priority and Fairness, APF, with concrete examples you can copy/paste and try. I'll explain the why, the how, the important knobs, how requests flow through the system, and give 2 realistic YAML examples, one from the official docs and one you can use to create a limited priority level. What is API Priority and Fairness, APF? APF is the kube server's flow control system that protects the control plane when traffic spikes or a client misbehaves. Instead of a single global max in-flight cap, APF classifies requests into flows, using flow schemas, and assigns those flows to priority levels, configured by priority level configuration. Priority levels get their own concurrency shares and, optionally, queues so that critical traffic keeps progressing while noisy/bulk clients are isolated. Main concepts, short. Flow schema, rules that classify incoming requests, by user, group, resource, verb, non-resource URL, namespace, etc. The first matching flow schema, highest matching precedence, decides which priority level a request goes to. Priority level configuration defines how a priority level is handled, exempt, not limited, or limited, shares of concurrency, queuing or reject behavior. Concurrency is expressed as nominal concurrency shares, which the API server converts into seats based on global in-flight limits. Seats, a seat equals 1 unit of concurrency. Some expensive operations, big lists, writes that trigger many watch notifications, are build multiple seats. Queuing and fairness, within a priority level APF uses shuffle sharding plus fair queuing to avoid one flow from starving others. You can tune queues, hand size, queue, length, limit. Exempt requests, long-running, some requests, health checks, leader election, some long-running ops, can be exempt from APF so the cluster can't be fully throttled. How a request is processed, high level. 1. Request arrives at kube API server. 2. It's matched against flow schemas, ordered by matching precedence, assigned to a flow schema name plus distinguisher. 3. That flow maps to a priority level configuration. If that priority is exempt, it executes immediately. If limited, APF determines whether seats are available. If not, the request is unqueued, per priority level, or rejected depending on limit response. Queues are assigned using shuffle sharding to separate high and low intensity flows. How total concurrency, seats, is calculated. With APF enabled, kube API server uses the sum of max requests in flight and max mutating requests in flight as the server's concurrency budget. That total is divided among priority levels in proportion to their configured shares. Managed services like EKS often document their defaults. For example, EKS uses 400 plus 200 equals 600 by default. Example: quick math. If total seats equals 600 and you define 3 priority levels with shares 30, system, 50, interactive, 20, best effort, then interactive gets 600 times 50/30 plus 50 plus 20, equals 300 seats, system 180, best effort 120. APF may dynamically adjust these limits at runtime. Useful debug and observability tips. Every API server response includes headers when APF is enabled, Kubernetes PF flow schema would and Kubernetes PF priority level would, useful to see what matched for a request. Debug endpoints, admin only. /debug/API_priority_fairness/dump_priority_levels, current state per priority level. /debug/API_priority_and_fairness/dump_queues, per queue state. /debug/API_priority_and_fairness/dump_requests, all requests, queued plus executing. Use kubectl get raw /debug /API underscore priority underscore and underscore fairness /dump underscore priority underscore levels to fetch them. APF exposes extra metrics you can scrape, API server metrics, monitor queues, executing requests, rejections, etc., to tune configs. Example A, official example, isolate expensive list events calls. This is taken from the Kubernetes docs example. It routes list events requests from the default service account in the default INS to the catch-all priority level so they don't disturb other work. API version, flowcontrol.apiserver.k8s.io/v1. Kind, flow, schema. Metadata. Name, list events default service account. Spec. Distinguisher, method. Type, by user. Matching precedence, 8000. Priority level configuration. Name, catch-all. Rules. Resource rules. API groups. Namespaces. Default. Resources. Events. Verbs. List. Subjects. Kind, service account. Service account. Name, default. Namespace, default. Apply it with kubectl apply f-list events default service account.yaml. Why this helps: list events can be expensive, many objects. Isolating them into a low-share priority prevents noisy list calls from affecting controllers, leader election, etc.